This is my 4.3 data collection PowerPoint by Alex Mulder. Okay, first we're just going to introduce it. So, research is done in ways to create different findings and to have different outcomes. So the main point of research is to create different ways in which you want to find outcomes, as the outcomes can't always be found in the same way. It's important to remember framework, so how it is set up and designed to be done. And it's also important to remember the method, which is the ways of analysing data and data collection, so how you actually take in the data and how you look at the data once it's been collected. It's important for the collection to be correct. This is because it causes robust and quality results, so if it's collected in the correct way, you're able to get good quality results, as it's the way it should be collected. You must consider certain questions when picking research design. You've got to look at if it's descriptive data, so if it's the data describing something observational, where you're watching something happen, and you have to take in that. And just also consider whether it's an experiment, so whether you have to manipulate something to find a certain result, if it wasn't manipulated. And you also got to consider the variables and participants, so you've got to consider who's involved, and also anything that could affect the actual research. You've got to consider that. That's very important. Okay, so next bit is research design. So it's important to first pick an appropriate design. So how you're actually going to find out what you want to find out. You've got to make sure it fits the piece of research, so it actually you can actually use this research design with your research, because if it doesn't fit, then it's not going to work. And then you've got to decide the actual method of how you're going to research, so how you're actually going to find out what you want to find out, and then decide how the data should be collected. So once you've done the research, how you want to collect in the data so you can see and analyse it, and how it's clear to you. One way of this is experimental. So experimental is a test with a predetermined prediction of what will happen, so that's the hypothesis, so you're going to guess what's going to happen. Then you go into analysing the data, and then reading the data and determining what you get from that. Experiments work by changing the the independent variable to find the dependent variable, and you control all the external variables, so there's nothing that can affect the data, and you're manipulating everything. Everything's observed under controlled conditions, so nothing can externally affect the results, so everything is how you want it. The research is an active agent, so the researcher actually is very involved with the test. This means the participant knows he's there, knows he's watching, and knows what's going on. So an example of this would be testing how different types of diets affect the ability of gymnasts to do a backflip. So you'd put gymnasts on different diets and see how they are affected to do a backflip. Next one is correlation. Correlation is comparing two sets of data of results to see a relationship. Is important. The word relationship is because that's what you're trying to find. You're trying to see if you can find a positive or negative relationship between the datas. The way it's collected is by scatter plot. So that's like a graph where you analyse the way the graph is moving, so you can see how the results are effective, and if the two different results are matching up to each other or completely different. Correlation coefficient, so the R value, is calculated using statistical test. It is between -1 and +1. You're really looking for the strength and direction of the correlation, so if the correlation is tight together, this is the good strength, and so it's the results are similar, so if it's almost like a line, that's what you want to be looking for, and a direction, so if the direction of the results are going up, that's a positive, and if it's going down, that's a negative. You must consider the inter and retest reliability, so because you're comparing two results, you've got to consider if the reliability with retesting it was fair, so comparing the results is actually fair, because if it's retested differently, then this could in fact affect the results, and the interreliability is the actual testing of the two results, done the same way. So an example of this would be comparing the results of how long a 20-year-old can balance compared to a 30-year-old gymnast. So how long can each balance using the same kind of balance, but you're really testing the age to see if there's a positive or negative correlation with this. Next one is comparative. This is where you compare two sets of data to form a conclusion. Helps check either if you have differences or mistakes. So it checks if one set of data is better to use than another. So like you're comparing which one is mainly better really. It checks for demand characteristics, checks for differences within the data. So something like if the data was done differently, if there was one demand characteristic that was different, would that be affecting it, and would that be the most dramatic change in it? It helped find which is a better method, could be a good example, which finds, if you're comparing two things, you could find which one's better to use. Example is comparing results of a 20-year-old athlete's full routine to a 40-year-old athlete's. So you're comparing the analysing them through probably video, seeing which one's better, seeing why they're better, seeing what they're doing better. So just comparing the results really. Next one is a case study. So this is an in-depth study looking at a specific person or group. So you're actually watching something specific and probably a broader thing, like a broader experiment or something like that. It has real life context as you're looking at like people in like real life situations and how they're acting and stuff like that. It's normally done over a long period of time, so you're looking at people throughout years and different kind of training sessions, stuff like that. It depends on what you're watching. It's narrative, and it can be narrative and measurement of individuals, so you're almost observing and describing what they're doing, but you can also take notes and results of how they're doing it. It has good realism as you're watching a person personally, and it's how they're actually acting in a real life situation, but it has low reliability and bias because you could see certain things and you could not see certain things, and that affects the reliability, and the bias could be the researcher wants certain results, so they could be more prone to write that than stuff they don't want to see. An example would be looking specifically at certain move in gymnast routine and why it isn't as good as the other moves. So you're watching the whole routine, but you're specifically concentrating on one bit to see why it's not as good as the other bits. That's a case study. The next one is cross-sectional. So this is observational and involves recording info without manipulating the data and manipulating the environment. So it's almost like an experiment. However, you can't change a certain site to find out something that you want. Using a range of participants with different backgrounds, age, genders, and different countries. So your cross-sectional is basically that. So you're looking at people from different areas to see the differences between that, but without manipulating it, so you can get an actual real broad view of it. Collect data from cross-sectional of a population at one point in time. So you actually take all the data at one time, so you don't take it over time. You take it exactly as they're doing the same thing, so it's fair. You're able to compare different variables as well. You can suggest cause and effect, so you can suggest why a different gender may have different results, but you can't actually prove it, so that's a negative. You can't actually prove that why. An example would be looking at how the weight of the gymnast affects how long they can hold a balance for. So you're not actually manipulating their weight, but you're actually looking at the actual different weights affect the impact of how long they can balance for. Next one is longitudinal study. So this is an observational study, so you're actually watching something, you're not manipulating or stuff like that. Measuring the same variables over a long period of time. So this is a study done over a long period of time, looking at the same people but in different phases of time. The researcher doesn't influence the participants, so they don't tell them they're being studied and don't tell them certain things, so they just see how they're acting naturally in a real life situation. It looks at the developments and changes detected in a group or individual, so you're actually looking at differences over a long period of time, whether they're improving or regressing, stuff like that. So an example would be looking at the ability for a gymnast to perform a backflip at the age of 20, 30, 40, 50. So you're looking at whether the progression of age changes how they are able to do a backflip and see if it affects them or not. Moving on from the actual study, so this is actually like data, the actual data that you get from these kind of studies. So primary data is the data collected and created by yourself, so data that you've actually come up with yourself. So it's your actual own research and findings. It's created by your own knowledge and resources, so you actually come up with it yourself. So you come up with the study experiment, how you collect it, how you analyze it, stuff like that. So an advantage of primary data would be it's direct, so it's actually yours. It's specific to what you want because you've designed it and you've made it and you know exactly what it is, and it's also reliable to you as you know everything about it behind. You designed it yourself. You can check it yourself as it's yours. Disadvantage is a risk of bias because it's yours. You might manipulate the results and want the results to go a certain way, so you might change that to play in your favour. It's also time consuming as you're doing the research yourself. So it might take a while to actually do that to get the results you want. And money and equipment. If you don't have the money or equipment, you aren't able to make your own primary data as you need to create your own experiment and stuff like that. So you might not be able to do this. An example would be creating findings that there is a correlation between a gymnast and their weight and their ability to balance. So you actually create a study looking into this. You collect the data yourself. You analyze the data by yourself, and that's what you come up with. The other type is secondary data, so data collected from other people's research. So it's not your own findings experiment, it's someone else's, but you're able to analyze it. It can be used for comparisons of your own research. So if you do research into this, you could look at someone else's research and see what they got. Or if you have lack of access to your own research, this could be used by you as an example of research into this. So an advantage of this is quickly available because it's the research is already done for you. It's inexpensive as you're not doing the actual research yourself. You're just looking at someone else's, so it doesn't cost anything. It's insight and support. So basically that means like you have a look at someone else's and they can support you on what you want to know if someone else is doing it as well. A disadvantage could be it might not be available, so if no one's ever done research into this before, the actual research might not be available for you to use. Insufficient detail, so you might not get the details you exactly want as someone else might not have done them for you, so you might not get the detail you actually want. And variable in quality, so some research you may look at could be better than others. This could affect how you analyse other researchers. You could analyse better because another research was better, so that could affect it. An example would be using and analysing using someone else's data of the reaction times of a 6-year-old gymnast and a 30-year-old gymnast, because you aren't able to do it yourself. So you're looking at someone else's data for this kind of stuff to analyse and see the outcomes. Okay, actual data collection. So data can be collected in many different ways. It largely depends on whether it is quantitative or quantitative data is in the way you collect it. So normally if it's numbers, it will be a different way than if it was like words and stuff like that. It also depends on so that's why I said numerically or in words. It also determines how you're able to analyze it once collected. So data collection really depends on how you want to analyze it. So if you want to analyze it in a certain way, looking at a table or something, then you do it a different way to something where you just want a list. There are 4 different types of data collection. They are discrete, ordinal, nominal, and continuous.